Hello everybody, my name is Sarah Lonkers. I am from RMIT University and you are joining me today for the interactive digital virtual workshop where obviously we're holding this event virtually. We're exploring the world of digital technologies today, where you all as participants today will be able to follow along with myself to code a digital output in your browser. And we'll get a little bit more into the activity shortly. I do want to introduce myself and also do an acknowledgement of country as well. So RMIT acknowledges the people of the Woiwurrung and Boonwurrung language groups of the Eastern Kulin Nation on whose unceded lands we conduct the business of the university. RMIT University respectfully acknowledges their ancestors and elders, past and present. RMIT also acknowledges the traditional custodians and their ancestors of the lands and waters across Australia where we conduct our business. So like I said, everybody, my name is Sarah Lonkers. I am an RMIT alumni. I graduated back in 2017 from a Bachelor of Information Technology, and I also majored in entrepreneurship. I've since gone on to the education space and doing a lot of workshops as well with various cohorts of people. And I've also got my own business on the side where I teach STEM education and have a greater focus on technology, as that is where I thrive best. But making sure that we've got outreach in regional parts of Victoria and for our disability community as well. So that's a really exciting thing that I get to do. And then on the side, I get to work here at RMIT to do workshops virtually like we are today. So that's a little bit about me. Feel free to go and check me out a little bit post this workshop as well if you would like to. But what you are joining today is Open Day for 2021 for RMIT. Obviously, due to COVID restrictions, we're not able to run a face-to-face Open Day. And so we've been able to put together this Next Fest Open Day in a virtual environment for you all. So welcome and thank you so much for joining us, even though I'm sure we're all feeling a little bit of screen fatigue. So welcome and good on you for getting down here on a Sunday as well. Today, what we are going to do is we are going to be coding a little bit of a Mandela Effect. So I'm just going to hit play on that one so we can have a look at what we will end up programming and doing. And so what's really cool about this is it brings in a combination of learning and a combination of industries, which for a bit of a taste tester kind of virtual day, it's really good to see how some industries can kind of cross over between one another as well. So today we will do some coding, which falls into computer science and technology. We will also, with any type of coding, we have a mathematics component to what we're doing as well. So we'll bring in and we'll start to see how maths meshes in with coding and how that helps produce this output that you're seeing on the screen here as well. And of course, like anything, things need to look good and they need to be visually appealing. So of course, there's a bit of artwork involved in this as well. The difference in this artwork here in what we're creating, I'm just going to keep that off again because it's kind of cool to watch it, is that we're not actually physically drawing ourselves, the artwork. We're using a combination of maths and coding to be able to build something once, create a pattern with that, and then tell the computer to be able to loop through that a certain amount of times to then replicate this one particular pattern, a total of, X amount of times, whatever we would like that to be. And so it's really cool because you're able to start to see how we, as people who are not very good at art, like myself, I'm not a very good drawer. I'm not a very good designer, but I'm really good at coding and I'm really good at maths. So therefore I can be good at art. I just have to work out the coding and the maths to the artwork as well. So that's really cool for us artistic people out there that aren't very good necessarily with doing it by hand. So that's what we will be coding today. There's a couple of things just before we kick off and I start doing the live demonstration and sort of talking through a little bit of that code and what it's doing, just to make sense of it. Is just a couple of things. So making sure that today we're using a Chrome browser. Look, most browsers are usually fine. We are using a particular piece of open source software through a browser that does work best in Chrome. So it's just best recommended to use a Chrome browser. You can try it with another browser. If it does freeze up on you, it would just be that there's probably some elements of the website that just can't handle certain browsers. So Chrome browser is preferred. And we will now go into the URL of where we will start doing some coding. So this here on the screen again is the output, and this is what we can look forward to being able to achieve in about half an hour's time. All right, so by this point I will assume that everyone has opened up their Chrome browser, and then just opening up a new tab there, and just up in the top here in the URL part, we are able to type in snap.berkeley/snap/snap.html. And so that there, everyone, is what you would like to put into the URL of your browser there. And just in a moment, I will hit enter. But all this is telling the browser to do is just to go along to Snap, and you can actually see that it remembers where that is and also grabs that down there for you. So if you've got that down there, you can either at this point hit enter, or you can actually come down and give that a click. Either or, you will be able to get to the next screen that you are about to see load. Okay, so if our internet is all quick enough, we should have had that one up and running. So you're going to see this screen. It's got a bunch of different things on there, and probably if you've never seen any code before, this probably looks a little bit daunting. The thing is though, it's not. It's actually really, really easy to understand. So I'm going to take you through a little bit of this and just kind of show you just how easy this is to understand. So first off, we have to the right here, we have our stage area. So just this little area here, and we have this little guy here, and that I can just pick up and drag around and move around on my stage wherever I like. So think of our sprite as a character in a game or an element on a web page somewhere. Okay. Now this is looking pretty familiar to that. So this is actually what is making that appear on there, the fact that this sprite is here. If I want to get another sprite there, I can just hit that, and you'll see that a new one comes up on here as well. If ever you need to remove one, you can just give that a right click on your mouse, click delete, and that one will disappear. For today's purposes, we only need one sprite, so that is why I've removed that second one. So we'll just leave him there in the middle of the stage, and we'll get back to what we're going to do with our sprite in a moment. Now, we also have a stage area, which we can click down here. When we click to here, you will notice that those blocks, those motion blocks, have moved away. So if I click back to the sprite, we have motion blocks. If I click back to the stage, we don't have motion blocks. Now, the only reason for this is because our stage, in theory, will always remain static, so not moving. And if we think about motion, motion is movement, and we're clicked here on our stage. So we don't need those blocks. So the program is smart enough to remove things that we don't need, that aren't actually going to do anything for us. So you will see that move away. If later you do need some of these blocks and you don't see them here, just make sure that you're not clicked here on your stage and you're actually coding up your sprite. Okay, so this is a very good way to do it, is I want to code my sprite now. I want to make sure that my blue blocks are here in the motion. If they are, then I'm on the right area. Okay, now we've got a few different categories up here. So obviously when we build things, even if that involves a little bit of hardware, we can do lots of different types of things. So we need different categories to break up those blocks of code to know where everything is. So motion, things to make things move on the screen, to make your sprites move on the screen. Looks are purple blocks, and they're all about how your sprite looks. Sounds, the pink blocks, and they are all different types of sounds that we can make. So you can set some instrument sounds, change tempos, and things like that. So it's pretty cool that you can kind of make your own music with code as well. We have a pen, which is kind of a darker green color there, and that is that we can make our sprites draw on the screen, change colors, and do some really awesome things there. We have yellow blocks here, which are called the control blocks. These are the ones that control the program or control a sprite or control something in what you've coded. So they're usually the ones that kick off a piece of code running and then executing and outputting something onto your screen. So these ones are really important because without these, we can't actually start any of our code. Our code can't be read by the browser. In sensing, we have in there some lighter color blue blocks in there. And those are more things around sensing different types of inputs. So things like clicking the space bar or clicking different keys, 1, 2, 3, 4, 5, etc., all the way up to 0. What happens when I click those buttons, kind of thing. So the computer senses that some input has come in during the program running, and then I get to do something. I have to do something else after that. And we, as the coders, would tell the program to be able to do that. Our operators is all of our mathematics in there as well, and we'll get into them a little bit later because there is a little bit of that work in what we're coding today as well. And also in here we have things like variables. So we're able to create basically a container, give it a name, and store some things inside there to help us run our program. And so we will set up a few variables today, and like the operators, we'll get into those once we've started coding. Now, the other thing that we just do need to point out, and it's the last thing, and then we're going to get straight into some coding, is that on Sprite, we also have this magical little tab here called costumes. And when we click on that, we're able to see here that we're able to actually put some different costumes in there as well. So what that means is that we can have our sprite. This can be grey at the start, but I could also make another 3 costumes here and have a red, a green, and a blue coloured little arrow there as well. So that allows us to be able to change what our sprite or character looks like on the screen, and which is really important today because that is something that we need to do. So right now I am just going to take just a little tiny pause, just give you about 30 seconds to just find yourself, finish clicking around a little bit, because usually when you are following along to a tutorial, you will be doing a little bit of clicking here and there. And in that process, as you are, if you've gone into scripts here at all and you have dragged out some blocks and you've got blocks and different things kind of sitting out here and connected up and that, fantastic, exactly what you should do when you first jump into something brand new. Though for the purposes of the demonstration coming up shortly, just make sure you've got a clear screen. You can just remove those like that. Make sure you give stop a click as well, and just leave your screen set up on control just like this, and we'll be able to kick off in a very quick moment. All right, excellent. All right, the first thing that we're going to start doing, everybody, is looking at our character over here, so our sprite. What we're going to do is we're actually going to give that a new name, something a little bit more meaningful. As you would have seen in our demonstration before, we've got, we're using a circular, so we're actually using an image that is labeled ball. So what we're going to do, just for the purpose of that, to keep our brains all in check, is we're going to give that name a ball, so that makes sense once we start putting some costumes in place. Now, what we're going to do is we're going to click onto costumes. We are going to be able to come up to this little folded page at the top. That would be familiar to everybody as the file button on most commonly used programs like Word and Excel and places like that. So just give that one a click. And then what I would like everyone to give a click next is just costumes there as well. This is going to bring up a little pop-up menu for us. And we're going to have a whole bunch of costumes that we can now import into our screen here behind this little pop-up. Now, unfortunately, there is no search function, so I do like to just grab from the bottom there and extend that up a little bit so we can just get as many as we possibly can up on the screen. And we don't have to scroll down too far at all because it's these balls that we would like there as well. So what we're going to do is we are going to just double click on that, double click on that, double click on that. And I'm pretty sure we need 5. I'm going to just double check that. Okay. So here is actually one that we have made earlier. And so I'm just going to double check. So we only need 4 of them. Okay, so I might actually get rid of purple today. All right. So we just need 4 of those balls. There will be 5 in there where we did go. So just choose 4 of those colours. It doesn't matter which ones. And the names here, ball A, B, C, and D, are perfect as well. So we don't need to adjust anything there. Just going to give everyone a moment just to get up to that page. Alrighty, next we want to do some coding. So we can't actually do any coding here. You'll notice if I pull a block out and try to drop it in here, it actually just spits straight back out to the left. So it's not happy going in there at all. So what we need to do is we need to make sure we are in scripts when we would like to write code. Then you'll notice that I can actually grab that block and it now actually stays inside my workspace there as well. So this is a block of code that we do need. We are going to use a range of all of these categories, which is why this particular program for today's workshop is a really good one to start off with, because you get to kind of see how all those categories relate together and how they're all going to piece together a piece of program output for us. So the first thing we want to do is that we want to make sure that we kick something off when we start our program. Now, start in this program is a green flag, just like in some car racing or any kind of race. We have stop, pause, and start. Start's going to kick off our code. All right. So that's what this first block does. We are using the pen. We're going to be doing a bit of drawing. You would have seen from that example at the start that we're drawing different colors. So it's evident we do need to make sure we do some pen work here as well. And we want to pen up. Okay, so we want to make sure we're penning up. Now, this first clear there is just inputted there so that every time you keep rewriting the program, that actually clears away. It clears away that previous image. So we have our image here. We've ran the program once. We give play a click. The first thing it does is it clears it and it starts again for us. So that's what that clear block actually does there. So now that we have our pen and everything there as well, what we want to do is we want to make sure that our that one of our balls here goes to the middle of our stage. So we want to move. So we go into motion and we just want to go to the middle of the stage. The middle of the stage is the corners X, 0 and 0. And what we're going to do is we're going to hit that to make sure that we do move to the stage. So if you want to test something, move it away from the middle, click start, and we can test it. That's working there. I mentioned variables earlier. Now, variables are a really fundamental thing in and around computer science concepts because they're very powerful and they allow us to do many things within a program. The best thing that they allow us to do is actually create what I like to explain a variable as is like a box or a container, okay? And it has like a lid on there and you can take the lid off and you can put a whole bunch of different stuff in there. So we might put inside one container, like in the kitchen, we might put some flour in there, then we label it flour. Once we use up all of that flour, we can wash that container and then we can put some sugar in there and we can label it sugar. So a variable is very much how we use containers in the kitchen and very much how we just, use boxes and things in general. We always put something in, take something out, relabel it. And variables are no exception to the rule. They are exactly that. So what we're going to do today is we are making a variable. we're going to make 2 variables because I already know ahead of time that we need 2 variables. And we're going to make the first one just n, and we're going to leave this for all sprites ticked as well. We're going to click OK. We're going to notice that our variable is created here now, and that's actually draggable, so we can do some things with that variable now. We're going to make another one, and we're going to have that as lowercase I, and we're going to click OK. Now, we don't want these necessarily up there. Sometimes when we create variables, we'll create a score variable, and it will make sense to leave the score up there because we want to see that because we're playing a game. In this instance, we don't really want to see that. How do we remove that? You'll notice there's some 2 ticks over here. Untick those, and those disappear. Pretty cool for us. All right. Now that we've created variables, we can use variables. We want to grab this set block. We want to set our capital N, and we want to set that to 12. Okay. And I'm just going to go ahead and put these blocks in, and then I'm going to talk you through what this code is actually doing. So I'm going to create a ball. Okay. So that's a little bit of our first code. Now, what this is doing here is I mentioned earlier that we're using maths to draw our art. So the really cool thing about maths and formulas is that we can actually do something once mathematically, so work it out. Here we're using n, and we're setting that to 12 points. And so we're working out of that 12, what does one of these rounds look like in terms of creating something. So this first one is the first kind of drawing of the Mandela Effect. And as you can see, what it does is it goes through those 12 points. It goes around in circular motion. So we're using 360 to divide by that 12. And every single time we finish, we're then creating a clone of the ball. So we're cloning ourselves to do this thing again. And we're also changing our costume. Now this next costume button triggers off a change to the blue ball. And then when it runs again, that code, it will trigger off a change to the pink and then a change to the green. And if we had more colors there, etc., etc. In our instance here, we only need 4. It's only going around 3 times because we're only getting to 12 points. So 4 times 3 is equaling that 12 there. So that's what this first little bit of code's doing. And I always like to just give it a little bit of a run and see what's happening. And you'll notice that it did do it. It went through all of the colors. Okay. So we started on, let's have a look at our costumes. You can see this with me. We started on yellow and we end up on green. So you can see very quickly that we kind of go through all our costumes really, really quickly. So I'm going to hit that play button again and we can observe our code working. So actually it went that quick, it almost looked like we had a little bit of purple in there. Now you will notice that once you test that, you have your ball's gone missing as well. So the way that we can make sure that our ball is there is we can just right click and click show. And so that'll work there. Now if you want to start on a certain color, you can. You just have to physically go and click that. Okay, so we'll go back to that. And we'll go back to showing the ball. So our first bit of code is working successfully, which is fantastic. Now you will have noticed we didn't actually draw or move anywhere. We stayed in the one position. So we've only actually told ourselves to go to position X0 and Y0, which is the middle of our stage, which is why the ball remains stationary. So now we're going to code the last piece of our program, which is the chunkiest bit of code that we have. And I'm going to do that. And so just follow along with me. And feel free to do, if you are watching a recorded version, feel free to pause down on the little bits where I am pausing after some code's written as well. Okay. All right, so now we have one and we've cloned. That's the biggest thing you want to take away from that code there, because the next starting block that we want is this when I start as a clone. So every single time you clone me, I now want you to go and do like a whole series of things. And we are going to be doing a fair bit. So I'm just going to move this code around here so we've got all use of our work zone. Now, the first thing we want to do is we want to move around a bit. We want to draw some stuff on the screen. Now, to be able to move around, we need to move quite significantly. So we're going to move around 150 steps. And then every single time, we're going to point ourselves in a slightly different direction and then go again, move another 150 steps. So what we want to do is we actually want to move in a square. So what we are going to do is use the magic number of 90. And so we are going to do that. And then we're going to go back into here and we have this direction block that's already there. Think of this as a variable, but pre-created for us. Okay. So what we want to do is we want to point in direction and then we want to like plus 90 and we want to move in that 90-degree direction. And I'm just going to very quickly flip back to here. And I want you to just notice, and if you can actually start to see that this is actually just drawing squares. So every single time we're just drawing squares. And that's how we're getting this effect here. And this bit of code here, this point in direction, direction plus 90, is doing that for us. Okay. So maths all the way for the win. We want to show ourselves. We did have a hind here. We want to show. We want to be seen on the screen. We also earlier created another variable. So we want to now use the set block. And we want to use the lowercase I variable. And we just want to give that a number to begin with. We don't want it to be 0. We actually want it to start at 1. So we're just going to set lowercase I to 1 on that block. Now we're going to go back to control. And we want to do a whole bunch of stuff and we want to repeat that. We want to repeat that a total of 12 times, coming backwards from 12. So we want to be able to tell the computer that I actually want you every single time to count down from 12. So repeat it once, and then I want you to work out what 12 minus 1 is, and that's 11. And then work out that this is 11 now, and then repeat again, and then work out 12 minus 2, and then work out that this is 10. So we want this number here to constantly be changing, and we want the computer to understand what that is and know when we get to 1 to stop. So how do we do that? Well, it's very simple. We are able to use some mathematics, and we just tell it with a formula. We just say I, which is what we set here. So, apologies, N. And we want to, every single time we've gone around once, we want to detract 1. So this will now create what's there like a counter. Okay. So it will start at 12, then it'll go to 11, then it'll go to 10, then it'll go to 9, 8, 7, 6, 5, 4, 3, 2, 1, and then it'll eventually be on 0 and the program will stop, which is where we end up shortly on our program here as well. There's one more iteration of it. So we've hit 12 times that we've done that. So now our program executes and stops and our balls go away and we've drawn our effect there. So that's what we've just coded here in this block, and we're going to place that in there so that we can just let the computer do its thing there. Now we're going to do more pointing in directions. So we are going to go into motion. I'm going to grab that one out there. We're going to do some more mathematics. We are going to put that there. And we also need to put an extra one in there. So just with these, they do start to look as though they get complicated. Now this one, there's all these different holes that you can put them in, right? This one we want in the second one, so if we put that in there, you get a lighter color green that comes in there, and you can keep stacking into these little ones here. So it can get quite convoluted, the maths, but we're not going to go that far today. Lucky ducks. And we're just going to put some numbers in here as well, and we're going to make sure that we just do a little bit and let it tell it what it needs to do. And that is also going to be using our variable n, so 12. Okay, when it starts at 12, when it goes through, it'll be 11. When it goes through, it'll be 10, 9, 8. So this, as this is changing here, the variable here is also changing and counting down from 12 because we're inside here. Okay, so do a little bit of that. Now, as we're doing that, we want to be penning down. We want to be drawing something. And we also want to get a little bit creative, and we want to change the hue around. So those different colors and getting some slightly different shapes. Now this here, this is your coding program. This is a particular block here that you can very comfortably change without breaking the program, because there is the maths involved. So be careful what you change around. You may break a few things, but that's all right. Rewatch the video, go back and fix the code. That's what it's all about. But this particular block is a safe block. You can change this. You can make this 70. You can make this 30. You can make this 5. You can make this whatever you would like. Okay, you're not going to break the entire program. Just make sure it's left on hue there though. And now within our repeat, we also want to do a particular little something again as well. So we're going to find our repeat block. I'm going to just attach that to the bottom of the change pen block. So not to the bottom of the repeat. Notice that the block goes the same color yellow. We don't want that. We want it to go a lighter color yellow there. So just make sure that occurs. We want to put in a move block. We're going to move around a lot more now. And this is where we are going to start to use the sin, cos, tan rules in mathematics. We're going to be using sin today. And so we are going to need a fair little bit of maths operations here as well. So what I like to do when I've got a bit of chunky code is to actually put all the blocks out below here of what I need to put into there and then slowly piece it together. So I know the first one that I'm going to need is a times there. I'm going to need 2 of those. And I'm going to need a divide as well. And I am going to need, I think it's this one. Yep, is sin. And I need to grab that one out there. Okay. So I know I need to do this 30 times. And I know that I need the sin into that one there. And then I need to also times some things and put that one into there. Okay. Now, because we're using variables, it means that I don't need to stipulate numbers a lot of the time. So I am able to just continually use these variables that I've created, which is why they're so powerful, and it cuts out so much coding. And so what we're doing here is we're going to put all of that block of code into there now. And that's how your code should look there at the moment. Okay, this is probably a really good time to pause or go back a little bit and rewatch. These blocks are a little bit tricky. And if something's not working at the end of the program, it's probably these blocks here and just the embedding of these blocks. So feel free to rewatch this recording a few times just to make sure you get that stuff right. Now, underneath this move block, we do want to just wait a tiny little bit. So you would have noticed that our program runs very, very quickly and does things very quickly. We don't want to wait 1 second. Believe it or not, 1 second in running programs is actually a very long time. So we actually want to go to 0.1 seconds. So just a very quick break for that little bit of drawing there. Now we're going to come outside just to below this embedded repeat block. So just below here, we're going to put another weight in there. This time we do, I've clicked something. So if that happens, if you click your code, it does execute. And we've lost our ball. So as you can see, we've not got all of our code, so we're not getting around in the shape that we need to at the moment. So it's kind of a good thing that happened. That's fine. If you want that back, you just click stop and that will stop lighting up like that for you. Now, in between all of this, we want to just wait a tiny sec. we want to grab a repeat block and we want to put that below that weight there. So noticing that all those light coloured yellows coming through, if they are just a friendly reminder coming through with the darker yellow, we're in the wrong spot. We just need to go up and make sure that it's a light coloured yellow there. Now, this one down here, we want to leave on 10. And we want to use this block again. So this block of code that we have here. So we want to duplicate only, so what we want to do is we want to right click on this and we want to duplicate only this block. So we don't want to click that, because if we click that, it's going to make a copy of our entire code that it's connected to. If you hover on the actual block that you see there, it will say only duplicate this block. And this is the one that we want to then left click on. And you'll notice that it's stuck without clicking anything else in your mouse. It's actually stuck to your mouse, which is kind of cool. We can move that around the screen. Now, where we would like to place this is inside that repeat block. So when we see that line appear, we can just left click, that will drop in there. And now what we want to do is we want to do the opposite of what we did here. So it's very easy with maths, is that if we want to do the opposite of something, we can just negate the number that we were using prior. So prior we were using a positive 30, and now what we can do is we can just negate that and write negative 30 just like that in there. Negative is just the dash key right next to the 0 key on your keyboard there. Like before, we want to weight as well. So we're going to just put that little block there, and we want to make sure that's 0.1 as well. And then, because we're doing this counting thing on this repeat here, we then want to set, just for good measure there, we want to set our I, and we want to now increment, we want to increment the I up as well. Okay, so that means that every time we go around, this will then change in value as well. Okay, so this setting of those blocks and then using those blocks with the mathematics is using them to change they're constantly changing their values that's set in there. Now we do need a little mathematical operation in there because we need to plus. So we need to put that there. We need to go back into variables, click that one there. And we're always additioning one. So one round is one loop. Okay, so that is our code. So we should all sort of be roughly up to that. I think probably by now, a lot of the time, people might sort of be sitting more around just up here as well. This is usually the confusion point here. But what we're going to do is we are just going to take just a moment of a little bit of a break. I'm going to leave this up on the screen. I'm also going to put some little background music in and take you back to nostalgic sea of the Super Mario Brother days as well. So utilize this time to watch the video, look through some of that code. If it's recorded, please feel free to press pause and finish that code and give it a test run, see what's happening, and see if you can see anything that's maybe not working so well and try and fix that up there as well. Okay, so without further ado, here is some Super Mario Brothers. Alright, we probably don't need an hour of it. Although for all of those nostalgic fans out there of Super Mario Brothers, And while we are in a bit of a lockdown period, if you are wanting a cool project to work on that is a little bit computer sciencey and techie, little Raspberry Pi, and the thing that you would be building on it is called RetroPie. And so you are able to get back all of those games that we used to play in the 90s and set up something with some newer technology about to play all those. So RetroPie, give that a bit of a Google post this workshop. There's something cool to do while we're all staying safe at home. All right, excellent. So this is the end of our workshop in terms of the live demonstration component. I do want to just friendly reminder, we'll just have this up on the screen as well. So if you realize just me talking with nothing happening can be a little bit dry. But basically, that's what we've done here today, everybody. We've used a combination of maths, coding, and to be able to draw some really cool artwork. And all we're doing effectively, as I mentioned earlier, and you can see now in the image too, is we're just drawing squares in a particular way, and we're getting this really awesome Mandela effect come across there. So once your code is working, I really encourage you to just test some things. So there are a few numbers that I did mention, like the hue change that you can make that different colors and things like that. Maybe you want to make it all one color. Maybe that's a really good challenge to see how you could make the entire Mandela effect the one color. And so that might be pretty cool to do as well. So there's lots of different things that you can sort of mess around with post this virtual workshop. Although there are other things that are happening as well. This is our virtual open day here, but there are things happening, obviously pending, restrictions and things like that, but things happening through September. So stay connected. openday.rmit.edu.au is our website. Please go on, register, and come along and sign up with your name in here as well. Even if you can't make it along to everything on open day, at least then you're on our mailing list, so we can email you through things that are going to be super important for some upcoming decisions for some of you. And I hope you've really gotten something out of today, and that it's inspired you to maybe head down the computer science, IT, software engineering. Maybe it's virtual reality or artificial intelligence that you're into, but that thing around that tech, that maths area, I hope that it's inspired some curiosity and shown you how easy it is actually to utilize coding and mathematics to build something. And so I wish you all very luck in the future, and thank you for having me, and enjoy the rest of your virtual open day for 2021.